So starting with continuous delivery in Tanzu Mission Control, this is all about driving the configuration and installed packages in your cluster through Git. So defining what you want your cluster to look like in a Git repository and having that synced through TMC to the cluster. So firstly, why do we want to adopt continuous delivery? So there are three primary reasons. Firstly, removing ClickOps, having consistent tooling across your organization, and then securing your operations. When we talk about ClickOps, that's kind of a colloquialism for doing things through a user interface or a CLI. What we want is automated tooling so that when you make a change to the source of truth, which in this case is a Git repository, that change is automatically reflected in your cluster without clicking through a user interface. And we want this so that we can streamline the installation of applications and Kubernetes resources and automate the distribution of these resources across a large number of clusters rather than clicking through and installing things cluster by cluster. So what continuous delivery enables us to do is define resources once in a YAML file and reuse this YAML file across as many clusters as you have in your environment. When we come to consistent tooling, what we hear from customers often is that development teams have one set of tooling and platform operations teams have another set of tooling, and it becomes hard to hand over responsibility of a cluster across teams. So what we see enterprises wanting is consistent tooling across teams, and development teams typically standardize on a GitOps model, and IT platform teams also want to adopt this model. So they can make the handover of cluster operations smoother when it comes to the IT team standing up a new cluster, getting it ready for a development team, and then passing it over to a DevOps or application operator to then make further changes that the developers require. And when we talk about security, this is really referring to having a single YAML file as the source of truth for your cluster configuration and installed applications. What this does is reduces the scope for cluster configuration drift because you're not applying different configurations to different clusters. You have the same YAML file being applied to all of your clusters. And we provide the ability to store credentials in Tanzu Mission Control. These credentials only propagate to the cluster when they are required by a repository that needs authentication. So we are reducing the proliferation of secrets in your environment. So firstly, who are we building for? We are targeting at the moment a platform operator. So this is someone who is responsible for defining the cluster, so the configuration, the operation requirements around that cluster, and defining the security standards that the cluster has to meet. So this includes deploying clusters, managing the lifecycle, so upgrading, deleting clusters when necessary, and installing the required add-ons to help developers and DevOps teams to build and operate applications. When we say add-ons, we're talking about installed applications and packages. So this could be monitoring tools, it could be an Nginx ingress controller, as a couple of examples. So that platform operator might have a repository pointing to cluster add-ons defined as Helm charts. So you're a platform operator and you have a bunch of Helm charts that you want to install in your cluster. You also might have value overrides stored as YAML. So these would be YAML files that define the values of certain parameters for those Helm charts. You might also have a Git repository storing YAML artifacts that you want to be applied to the clusters. And we'll talk about what those YAML artifacts in more detail. We'll talk about what those YAML artifacts are in more detail shortly, but some examples right now would be namespace definitions, pods, and installed applications. And so you have these two repositories, and what you want to do is sync the contents of these repositories to new clusters so that you can automate the configuration and installation of applications when you add a new cluster to Tanzu Mission Control. Typically what happens today is that a platform operator would create a new cluster, then they have to go to that cluster and manually create all these Kubernetes resources and installed applications. What we want is to be able to create the new cluster in Tanzu Mission Control and then automatically apply all these things that are defined in a Git repository. So the steps that you would take through Tanzu Mission Control are firstly, write YAML. Now this obviously happens outside of Tanzu Mission Control. You would write a YAML file and store it in a Git repository. It doesn't matter where that Git repository lives. It could be in your data center, it could be hosted on the internet somewhere, and it could require authentication as well. We support authenticated repositories. You would add that repository to Tanzu Mission Control and point Tanzu Mission Control to the path where your YAML is stored in that repository. Once it's connected to Tanzu Mission Control would sync the YAML from that repository to the cluster. So any resources defined in your YAML file will be created in your cluster. Now let's dig into that one more level of detail. So when it comes to writing YAML, you would write these artifacts, store it in your repository, as I mentioned. These YAML files can define overlays to existing resources or define new resources. This is an important point because the technology that we build this on is called Customize. Customize is typically used to define overlays to things like Helm charts. But in this case, we can also use it to define new resources, things like new namespaces, new pods, etc. And there are some examples of resources listed here, but essentially it would support anything that can be defined as a YAML file. So any Kubernetes resource, any custom resource, and installed application, for example. Then when you come to add your repository to Tanzu Mission Control, you would first create your repository credentials in Tanzu Mission Control if your repository requires authentication. Like I said earlier, repository credentials are only propagated to clusters when they are required by a repository. So we don't just create any credentials in the cluster, they're only created in the cluster when required. Then you would add customizations. Customization is jargon for the customized technology, but essentially what a customization is a YAML artifact or a YAML file defining YAML artifacts. So you would add your customized file to Tanzu Mission Control, and these are folders in your repository where your YAML artifacts are kept. So that's what we're actually syncing from your repository to the cluster. And the third point here, when it comes to syncing YAML to the cluster, Tanzu Mission Control will periodically check your repository for changes and sync those changes to the repository. The default interval time that we set is 5 minutes, and we are introducing a feature to allow customers to change that interval as well. So when you make changes in your repository, these will automatically be reflected in the cluster. You don't need to do anything in Tanzu Mission Control after that initial setup. We will handle it based on the sync interval that is set. If you come to delete anything from Tanzu Mission Control, so deleting a customization, for example, there's a setting that we included called prune. Now this is something that we inherited from the technology that we built this feature on called Flux. And what this means is that if you enable prune, Tanzu Mission Control will remove the cluster resources that were defined by that customization when you delete the customization from Tanzu Mission Control. So if your customization is a YAML file that defines a new namespace or a new pod, that namespace or pod will be deleted when you delete that customization, only if you enable the prune feature. If prune is disabled, and the default is for it to be disabled, your cluster resources won't be affected. And we'll look at exactly what this means when we come to a demonstration at the end. So we walked through why we want this feature, what the feature is, and the steps you would take to get from writing a YAML file to syncing it to a cluster. Now this diagram explains how we actually built this feature. So if you're an operations team, a platform operations team, you would come to Tanzu Mission Control, you would create your credential, you would attach your repository, and you would point TMC to the path in that repository that you want to sync to the cluster. Then what TMC does is installs Flux CD in the cluster. We actually install the Flux source controller and customized controller. They're two different controllers that are required for this feature to work. And then we orchestrate Flux. So we connect your repository to Flux, and we tell Flux where to look in the repository and what to sync back to the cluster. And so Flux actually connects to the repository directly and then creates the resources that you've defined in your YAML files. Some important notes about how we actually built this. Firstly, Flux is fully managed by Tanzu Mission Control. A Tanzu Mission Control user would never have to interact with Flux directly if they didn't want to. Caveat related to that, some enterprises have operations teams that want to use TMC, and in that case, they would never interact with Flux directly, but you might have development teams working in the same cluster who want to access Flux directly. That's totally okay. The Flux instance can be shared across different teams. It can be used for multiple purposes. Okay, so what I've described is the first step that we've taken to introducing GitOps into Tanzu Mission Control. There is quite a large roadmap when it comes to GitOps in Tanzu Mission Control and across Tanzu in general, because where we want to go with this is to enable enterprises to scale up their Kubernetes environments with Tanzu Mission Control to hundreds, if not thousands of clusters. And we want to enable that scale up without adding additional operational overhead. So with that in mind, the next step in the technology evolution of this feature is to enable continuous delivery for cluster groups in TMC. A cluster group is a logical grouping of clusters. And what this would mean is that you would go through that workflow that I described earlier of attaching a repository and pointing TMC to a path in that repository, but you would do it against a cluster group. Tanzu Mission Control would then take that configuration and apply it to every cluster in the group. So you would go through that one workflow for the group, and then you would get that result for every cluster in the group. So if you have 100 clusters in the cluster group, you would complete that workflow once, and every one of those 100 clusters would get that YAML file synced to it. So this is a way of scaling up the environment without scaling up operational overhead. The middle column here is talking about GitOps for Tanzu Mission Control. This is a slightly different concept, and it's something big that we're planning in the future. We want to drive the Tanzu Mission Control product itself from a Git repository. What that would mean is any resource that exists in Tanzu Mission Control could be defined as YAML in a Git repository. You would point that repository to Tanzu Mission Control, and then the resource would be created in Tanzu Mission Control. So instead of pointing the repository to a cluster, you're pointing to Tanzu Mission Control itself. The benefits of this, firstly, would include troubleshooting and monitoring assistance. If the resources are created in Tanzu Mission Control, we have awareness of what you're creating in your YAML file. When we sync YAML files directly to a cluster, Tanzu Mission Control does not know what is being synced. So we can't help if the YAML file is written incorrectly, for example, or if something in the YAML file is behaving not as expected. But if we sync directly to Tanzu Mission Control, we actually can help with troubleshooting when things go wrong. We can also enhance the GitOps approach to include features that are included in Tanzu Mission Control, but are not Kubernetes features. So things like configuring policies, anything related to cluster groups, defining cluster groups, working with workspaces, which are collections of namespaces, and defining installed applications from Tanzu Mission Control's catalog as well. So we can drive the catalog feature from a Git repository. We also want to include the integrations features that we have in Tanzu Mission Control, so you can enable things like integrating with Tanzu Observability and Tanzu Service Mesh. Lastly, the third column related to app deployment and lifecycle management. This is where we get more into that topic of consistent tooling across the organization. So we've built these features for platform operators, and now they need to hand over some tooling or some responsibility of cluster management to an app operator. And an app operator might want to do things like install supply chains and configure supply chains for their development team to use. So we want to be able to drive all of their operations through a GitOps approach as well. And that would include things like integrations with Tanzu application platform for managing and monitoring supply chains, and It might include things like integrating with the scanning tools available in Tanzu application platform as well. So you can see our roadmap here is really geared towards assisting enterprises with scaling up their infrastructure and then working better across teams.